The National Electrical Code, specifically Section 250.118, addresses the use of rigid metal conduit, or RMC, as an equipment grounding conductor. It's important to understand what the code permits and what it restricts. The specific text of Section 250.118 does not contain a prohibition against using Schedule 40 RMC for grounding electrode conductors. This means that, according to the code's literal wording, Schedule 40 RMC could be used for this purpose. However, it is critical to consider other factors and related code sections to ensure a safe and compliant installation. Firstly, the suitability of any raceway, including RMC, for use as an equipment grounding conductor depends on its ability to provide a low impedance path for fault current. This is essential for facilitating the operation of overcurrent protective devices like circuit breakers or fuses, which quickly de-energize a faulted circuit. Secondly, the mechanical strength and durability of the raceway must also be sufficient for the environment in which it is installed. This consideration becomes particularly important in locations where the raceway may be subject to physical damage or corrosive conditions. Schedule 40 and Schedule 80 RMC differ primarily in their wall thickness. Schedule 80 RMC is a thicker wall than Schedule 40, which gives a greater mechanical strength and resistance to physical damage. This difference in wall thickness also affects the conduit's trade size and internal area, but for grounding purposes, the mechanical strength is the more critical factor. Thirdly, if the RMC is being used as the equipment grounding conductor, it must be properly connected to the equipment and the grounding system. This involves using listed fittings and connectors that are specifically designed for grounding purposes. These fittings ensure a reliable electrical connection and maintain the integrity of the grounding path. Let's delve deeper into the requirements and considerations. The NEC specifies the conditions under which metal raceways can serve as equipment grounding conductors. If RMC is used, it must provide a continuous electrical path back to the source. This continuity is crucial for safely carrying fault current. The code also dictates that the RMC must be securely fastened and supported. This prevents the raceway from becoming loose or damaged, which could compromise the grounding path. It is important to note that while the code may not explicitly prohibit Schedule 40 RMC for grounding electrode conductors, local amendments or project specifications might impose stricter requirements. Therefore, it is essential to consult the local electrical code and any project-specific documents before making a final decision on the type of RMC to use. Consider the environment where the RMC will be installed. In areas subject to physical damage, Schedule 80 RMC might be a better choice due to its increased strength. Similarly, in corrosive environments, the RMC should be made of a material that is resistant to corrosion, or it should be properly coated to prevent corrosion. When using RMC as an equipment grounding conductor, the connections must be made properly. Use listed fittings that are specifically designed for grounding purposes. These fittings will ensure a secure and reliable electrical connection. Regularly inspect the RMC installation to ensure that it is in good condition and that all connections are tight. Any damage or loose connections should be repaired immediately to maintain the integrity of the grounding system. In summary, while the NEC does not explicitly prohibit the use of Schedule 40 RMC for grounding electrode conductors, it is crucial to consider factors such as mechanical strength, environmental conditions, and proper installation practices. Schedule 80 RMC is often preferred in situations where greater mechanical protection is required. Always consult the local electrical code and any project-specific requirements before making a final decision on the type of RMC to use. It is crucial to understand the difference between equipment grounding conductors and grounding electrode conductors. Equipment grounding conductors connect non-current carrying metal parts of equipment to the grounding system, providing a path for fault current to return to the source. Grounding electrode conductors, on the other hand, connect the grounding system to a grounding electrode, such as a ground rod or metal water pipe. While Schedule 40 RMC might be acceptable for certain equipment grounding conductor applications, it is generally not recommended for grounding electrode conductors, especially in situations where mechanical protection is critical. The choice between Schedule 40 and Schedule 80 RMC depends on several factors. Evaluate the potential for physical damage. If the RMC is likely to be exposed to impact or abrasion, Schedule 80 is the better choice. Consider the environmental conditions. In corrosive environments, use RMC that is made of a corrosion-resistant material or that is properly coated. Ensure that all connections are made properly using listed fittings. Regularly inspect the installation to ensure that it is in good condition. Always consult the local electrical code and any project-specific requirements before making a final decision. Let's talk about the importance of proper grounding. A properly grounded electrical system is essential for safety. It helps to protect people from electric shock and it also helps to prevent damage to equipment. When a fault occurs in an electrical system, the fault current will flow back to the source through the grounding system. If the grounding system is not properly installed, the fault current could flow through unintended paths, such as through a person's body, which could result in serious injury or death. A properly grounded electrical system also helps to prevent damage to equipment. When a fault occurs, the fault current can cause excessive heat, which can damage or destroy electrical equipment. A properly grounded system will provide a low impedance path for the fault current, which will help to minimize the amount of heat generated. The NEC provides detailed requirements for grounding electrical systems. These requirements are designed to ensure that electrical systems are installed safely and that they will function properly. It is important to follow these requirements carefully to protect people and equipment from electrical hazards. Consider the ampacity of the grounding conductors. The grounding conductors must be sized properly to carry the maximum fault current that is likely to occur. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the other current protective devices. Ensure that the grounding conductors are properly connected to the grounding electrode system. The grounding electrode system must be properly installed and must provide a low impedance path to ground. The NEC provides detailed requirements for grounding electrode systems. Regularly inspect the grounding system to ensure that it is in good condition. Any damage or loose connections should be repaired immediately. The selection of RMC schedule depends on the environment. If the RMC is installed indoors in a dry location and is not subject to physical damage, Schedule 40 RMC may be acceptable. However, if the RMC is installed outdoors or in a wet location, or if it is subject to physical damage, Schedule 80 RMC is the better choice. When in doubt, it is always best to err on the side of caution and use Schedule 80 RMC. It is important to understand the difference between listed and unlisted equipment. Listed equipment has been tested and certified by a third-party testing laboratory, such as Underwriters Laboratories or all. This equipment meets certain safety standards and is suitable for its intended use. Unlisted equipment has not been tested and certified by a third-party testing laboratory. This equipment may not meet safety standards and may not be suitable for its intended use. When selecting electrical equipment, always choose listed equipment. This will help to ensure that the equipment is safe and that it will function properly. Make sure that the equipment is properly installed according to the manufacturer's instructions. Improper installation can void the warranty and can also create safety hazards. Regularly inspect the equipment to ensure that it is in good condition. Any damage or loose connections should be repaired immediately. Consider the voltage rating of the equipment. The equipment must be rated for the voltage of the electrical system. Do not use equipment that is not rated for the voltage of the system. Think about the amperage rating of the equipment. The equipment must be rated for the amperage of the circuit. Never overload a circuit. Overloading a circuit can cause the wires to overheat and can create a fire hazard. Reflect on the importance of electrical safety training. The electrical safety training is essential for anyone who works with or around electrical equipment. This training will teach you how to identify electrical hazards and how to work safely around electricity. If you are not properly trained, you could be seriously injured or killed. Take an electrical safety training course and follow all safety procedures. Always de-energize equipment before working on it. Verify that the equipment is energized using a voltage tester. Never work on energized equipment unless you are properly trained and have the proper personal protective equipment. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Be aware of your surroundings and watch out for electrical hazards. Never work alone. Have someone nearby who can help you in case of an emergency. Know what to do in case of an electrical accident. If someone is shocked, do not touch them. Call for help immediately. Turn off the power if possible. If you cannot turn off the power, use a non-conductive object such as a wooden stick to separate the person from the electrical source. In summary, selecting the right materials, including the appropriate schedule of RMC, and adhering to proper installation and maintenance practices are paramount for ensuring a safe and reliable electrical system. Always prioritize safety and consult with qualified professionals when in doubt. Remember that electrical codes and standards are constantly evolving, so staying informed about the latest requirements is essential for all electrical professionals.